Hey, good morning, good afternoon, and good evening, all. Hope I'm audible to all of you.
Yeah, right. I can hear you. Right.
All right, thank you. In this session, we will be taking you through our journey with Druid on user behavioral data analytics. I am Arith, working in Lighthouse Analytics team at PayPal. With me, I have my friend and colleague Mohan Raj. He is from Big Data Cloud Platform team. He and his team manages Druid clusters for our use cases. All right, here is the agenda for this session. We will talk about user behavioral data analytics with analytics and its and then we will cover why did we pick our use cases, then our architecture, different use cases that we have powered through Druid, our tunings, finally our Druid cluster and its deployment details. So let's try to understand what is user behavioral data and its importance. In order to understand user behavioral data analytics, we need to understand what is user behavioral data. User behavioral data is generated as a response to customers' action in any online platform. This captures what exactly user engagements are. A button click, scrolling up and down in a web page, swiping in a screen, transitioning to another web page are examples of user behavioral data. These data are sent as events to server from the client devices. And these events are the building blocks of behavioral analytics. Events represent an action a user perform in your product or any activity associated with the user. Example, making a payment, making a purchase. These are user behavioral data. Sending optimal data to your analytics platform is the most important step towards understanding how your users are engaging with your product. Now, why is it important to capture this information? Why do we have to capture user behavioral data? Behavioral analytics provides action taken by your users. By organizing this data into timelines, it gives you a journey taken by each of your user. By studying this journey, we get we can clearly determine user preferences and adjust products and services to suit your users. So with this data, you get a clear picture of how your customers are behaving in relation to your marketing efforts on your website. Behavioral analytics helps you identify new opportunities that may have been missed otherwise. So with user behavioral analytics, we get answers for these questions. How users respond to changes in your existing feature, or how well marketing campaigns are received by users, the time it takes from initial interaction to conversion. Is a new page bringing higher engagement than the older one? Our customers are able to complete a checkout. These are some of the questions to which we can find answers easily with user behavioral data analytics. Now we understand what is user behavioral data and user behavioral data analytics. Now let me explain you why we chose Druid for this particular data analytics. Interactive insights. Druid is really good at being able to group or rank on various attributes at query time uh, at query time at interactive speed. This gave the confidence for us to build interactive visual analytics for our users. Massive data ingestion. We wanted a solution where the system can take billions of events per day and also maintain 6 months of data retention. Our average data ingested per day is around 5.5 billion events per day. We wanted a solution that can handle massive data ingestion. And of course, a scalable solution. At PayPal, we have seen year on year data growth of 40 to 50%. We wanted a solution that is easily scalable. Then low query latency. As I mentioned earlier, we wanted to build an interactive visual analytical UI. So it was important to have sub-second latency for the underlying database. Time series data. Druid is optimized for storing and serving time series data, and it has time-based partitioning. Behavioral data is time series. So with Druid, it is easy to slice and dice your data along with time filters. Real-time and batch ingestion. Druid supports both real-time and batch ingestion. Real-time ingestion brings fresh data to the UI. So these are some of the key reasons to choose Druid for our use case. Now, let me cover on the architecture. Behavioral data is collected from client devices as users interact. These events are sent over network to our backend services, backend endpoints. And these services publish the received events to Kafka topic. We have both batch ingestion and streaming ingestion. In case of batch ingestion, we have a Goblin job which consumes data from Kafka and then writes the data into HDFS. Later, a Spark job which gets the data from HDFS and does the processing, post-processing using a Hadoop batch ingestion. The data is ingested into Druid for query. And when it comes to streaming ingestion, there is a Spark streaming application which consumes data from Kafka topic, does enrichment and processing, transformation on the events, and the transformed events are published into another Kafka topic. And through streaming ingestion from Kafka topic, data is ingested into Druid, and our UI is powered from this Druid cluster, from this Druid database. Now, we understand what is user behavioral data and what is user behavioral analytics. Let me explain you three use cases that we are powered through Druid for the user behavioral data analytics. Page flow analytics. CPL, which is customer perceived latency, and general reports. Page flow analytics help you analyze and view all the paths or popular paths users are taking for doing a specific task during a visit to PayPal site. I'll explain more on page flow in the upcoming slide. CPL stands for customer perceived latency. This is actually the real user monitoring. Data is collected from the browser with respect to each page load time, render time, SSL time, DNS time, and this information is captured and to understand how each page is performing with respect to latency. And coming to general reporting dashboard, this dashboard analysts can use to slice and dice the data with available dimension metrics to compare monthly reports or identify trends and patterns. Now let me explain more on page flow analytics, which we just covered now. Page flow analytics is a graphical representation. The picture in this slide is a screenshot from our dashboard. Each box represents a page. As you can see here, this view helps you to identify traffic distribution by browser, the common paths users have taken, and the average amount of time users spent in a page. The green portion of this box indicates the users that have visited this page, and from this page they have traversed or navigated to the next page. The red part shows that users that have stopped their browsing in this page. So this gives you a complete picture or complete understanding for the users, how users are using, how users are navigating, which are the common paths users are taking across your sites. Some of the user some of the user behavior you can learn from the page flow reports are: identify in which page visitors spend most of their time, which source which source of traffic or which promotion bring the most number of visitors. As you could see in the first portion of the picture image, right, it is classified through browsers, from which browsers we are getting. You could also find out from which country, for which region, or which promotion brought more traffic to a particular page, or which page has the highest drop-off rate. Is users arriving from your advertising campaign have a different pattern, or they behave differently than your regular users? All these kind of uh, analysis can be easily done on page flow reports. This is powered from Druid. Coming to CPL, as I mentioned, customer perceived latency. It is very important to understand how is the performance of each page with respect to page load time, uh, when the page is interactive, and how is the DNS latency looks, how is the SSL latency looks when a user is accessing from a different region. It can differ based on region, based from various factors: browser, the operating system that you use, the device that you use, the internet that you're using. It differs, like, based on various factors. This can vary. It's very important to understand how each of these pages are performing on these different scenarios. So these data is captured and ingested to Druid for better analytics. Now it is easy to identify underperforming pages in different regions and compare their performance in different browsers and with different operating systems. You can slice and dice and get the root cause where is the problem, or which kind of user category or user base is having a problem. These reports help you to drill down and identify the reason for pages to underperform. Coming to our general reports, this is the very basic slice and dice use case, the classic Druid use case. This is well, here users can slice and dice on about 90 plus dimensions and 10 metrics. All the user behavioral data is ingested to this Druid data source, and some of the dimensions are page names, device names, link name, the browser type, uh, and some of the metrics we have is page views, unique visitors count, the clicks, and etc. Now let me cover you some of the tunings that we have done for our ingestion jobs. So we have done a tuning to reduce the time that ingestion job that takes. The batch Hadoop ingestion job used to take a higher time. When we have verified and identified the root cause, there are two reasons why these jobs were taking higher time. The one reason was the input data was not well organized, or it was not uniform, right? The number of files that we had, some files were higher in size, some had like lower in size, and this actually caused some mapper job to run for a longer time, and hence overall ingestion time was taking longer than uh, expected. So by repartitioning this input data, the source data, by repartitioning and ensuring the data is well partitioned, and that help us to reduce overall ingestion time. And again, configuring the target partition size. As per the documentation, it was very clear that about 500 MB or half a GB is the preferred size for targeted partition. If it goes beyond that, it can actually create it will have an impact on ingestion time as well as latency on querying the data. So when we have configured 500 MB as the target partition size, we could reduce the overall latency for ingesting our hourly data into Druid. And another tuning that we have done is a regex based search. The page flow analytics, which I've explained, we have a feature that a user can search for a page using a regex pattern. And we had seen this regex search takes higher time, and we could reduce this regex search time by changing the uh, bitmap index type to a roaring index instead of concise. From 0.18 version onwards, this is the default bitmap indexing. But if you're on previous version, it makes sense to change this. It actually it gives you good performance with respect to regex searching as well as your filter conditions. These were some of the tunings that we have done for our ingestion jobs. Now, Mohan Raj will cover details about our Druid cluster. Over to you, Mohan.
Hi, thanks, Harry. Can you hear me?
Yes.
Yeah. Hi, everybody. Good morning. I am Mohan Raj. I'm architect serving as a senior platform engineer in PayPal, working in big data and cloud platform engineering. I'm also active member in Druid and Hadoop communities. So we are going to go over a sequence of slides leading to different types of implementations that are done in the large scale in the space of the Druid, and also engaging with the different variety of projects. So as Harry mentioned, Druid is primarily used in PayPal for business intelligence queries for the event data, and there are also different use cases for logging and alerting, and monitoring to generate the metrics that are used for rendering the projected graphs, and alerting the users and analyzing the traffic behavior and the historical trends. We mainly use Druid 0.17, and recently we are using the Druid 0.20 versions from the Apache Druid. So we serve, the platform team serves the dev, QA, Druid clusters and the production clusters that are taking the production traffic for different analytic purposes. So down the line, it has replaced the ULAB system, I would say, to use Druid especially, and that is addressing the critical latency issues. And also the existing OLAP systems has some inherent deficiencies during ingestion and also querying as well due to its limitation on architecture while aggregating the queues. And moreover, say for instance, if you take on Tableau dashboards where when the traditional database did not scale and perform in large scale for many use cases. So in this, jumping to this diagram, this, I mean, the raw data basically comes from the upstream in different categories. They feed the, I mean, the application team feed the data. They have two different pipelines. One is for the batch ingestion and for the stream ingestion. Normally, for the batch ingestion, they load the data into the HDFS. They do the cleansing activity to avoid any duplication, and then runs the ingestion job into the Druid. Whereas for the direct streaming, they use a Druid streaming pipeline. So all these are driven by the enterprise schedulers or the airflow schedulers. And on the other side of the data exploratory engines, like Varied mentioned, the custom analytic applications generated by the application team, they use the Druid API for their exploratory analytical web interface application. Or some team uses the superset and with the IO availability, and also the Grafana. So this, and also if you see the uniqueness of this particular large scale clusters, the data is tied in terms of art, warm, and code. That's how it's implemented in the bigger cluster, and where especially the cold is used for the HDFS deep storage, and the warm basically the SSD. You're using the SSD. Say it's ranging from the for 10 terabyte to the 30 terabyte SSDs, and out of course the memory that is used for the caching. So why are we using the HDFS deep storage? Because Druid uses this HDFS in this case deep storage to backfill the data onto the historical nodes. The main advantage is that during scaling, during the flexing up of the new Druid historical nodes, it refers whatever the segments it's responsible for for and from the deep storage and not from the other running historical nodes. And the another point, right, where for the schema evaluation, so where we have to configure the Druid about which data segments are supposed to go for which tier of historical nodes. We have a proper setting up of the appropriate load and drop rules, and also the replication factor for each data source, and of that too, it's greater than one in the coordinated process tools. So this, I mean, going to the next slide. So this side talk about the large scale implementation and continue to that, where there is an high availability in the Druid cluster starting from the overload, the coordinator, and the brokers, and the historical process are installed and configured on multiple nodes that are distributed among different hardwares. So the zookeeper, as we know, that's used mainly for determining which node is active, and other nodes supporting the each process that are in standby state until the active node starts. And that's a distributed coordinator engine that's running in a typically 5-node quorum is used in the Druid orchestration. And the metadata storage, we normally prefer to use the MySQL HA for the persistent information about the Druid segments and the task. For the batch ingestion, so we configure the Druid cluster to talk to the Hadoop engine, Hadoop cluster. Beyond task uses the MapReduce jobs instead of native ingestion for processing the large amount of data. So there is no HA for the brokers, as you know that, because all the other nodes have the high availability, whereas there is no HA for the brokers, where the multiple instance of the broker process is required for the HA. So normally we implement the external virtual IP address, the load balancer, so that the underlying broker pools is used and the user queries the virtual BIP basically. So that benefits the flexing up of the brokers, scale in and scale out depending upon the load. Let's go to the next slide. And also the challenges. Okay, what about the challenges that are faced in this large scale implementation and that we have implemented to cross to overcome the challenges. So current Apache Druid version does not have the automated installation and configuration suite, and the configurations and customization to address the interdependency of the Apache Druid is manual effort. And the rolling restart of the services, and for also and addressing the ad hoc configurations, reconfiguration of the Druid cluster is not just directly possible in the Apache Druid. And also there is no monitoring health and suite is available in the Apache Druid. So to address this, we have implemented a custom automation, and so this custom automation leverages the simple Druid management. It just simply enables the cluster, and it provision and handles the configuration of this cluster so quickly. And there is a centralized management and to start and stop the cluster, and then the rolling restart of the cluster. And we use this using Ansible, and because the Ansible is the agentless and it's open source and it's simple to provision and manage and deploy it. So that is the complete automation suite that we leverage to overcome the challenges that faced for large scale implementation of the different variety of the clusters. So going back to the next slide. So yeah, so that is a typical cluster where the master server we use, as I said before, we use a quorum for 5 zookeeper quorum. There's always better to have an overload of high availability of 3 and a coordinator and 2, and the data server is basically tired, and where the middle manager is also tired in such a way the slots are configured for the ingestion job as well as for the compaction for the Druid compaction job as well. There is a Druid compaction job runs by default, and all the historical nodes are tired. And the tired is basically the data that is tired across the SSD and the memory and the deep storage. Whereas the historical tier itself, right, each data source is regrouped. Basically, say if you take two different data sources, or you take any dedicated, for example, you take any one data source, that data source segments only to a group of historical nodes, not beyond, not to the different tiers. So this type of implementation is the management of the Druid cluster. Say if there is say if there is a refilling of the segments is required for any kind of major outage, this tier mechanism, it generally improves the availability of the Druid cluster. Let's go back to the next slide. Okay, this slide talk about the how the Druid is deployed using the the complete automation suite, where the administrator, cluster administrator gets the onboarding requirements from the different project team, and once he finalizes the onboarding requirements, and he just based on the finalized cluster specs from the project team, he uses there's Ansible Jinja templating being extensively used to generate the dynamic expression, and to also access the variables to implement the custom configuration for the specific Druid cluster. Because each different Druid cluster will have a use case specific for to serve the purpose. So this is once this onboarding and the finalization of the cluster specs is completed, the centralized playbook now will be executed by pulling it from the GitHub, and then it has several child playbooks to address the orchestrate the cluster. So first it set up the MySQL HA, and then it set up the Zookeeper playbook is initiated, and then the coordinator and the overload playbook is executed, and the broker playbook will set up the broker nodes, and middle manager will configure all its own configuration, starting from the JVM configuration, the runtime properties, and the common properties, and then the historical playbook will configure the historical nodes, and then the Druid cluster as nodes will be configured to connect to the external Hadoop cluster. This playbook, once it completes all the tasks end to end, it finally runs a Wikipedia canary job, the batch ingestion job, before releasing it to the cluster. So this entire automation end to end to provision and manage the cluster is completely handled by this playbook. So this easy, the the bare metal VM provisioning of the Druid cluster, and it reduces the cluster creation time. So normally the cluster creation time for a typical 100 nodes, I would say, take around 40 minutes to 50 minutes, depending upon the requirements. Yeah, can go to the next slide. Yeah, this slide talk about the metrics monitoring bot, where we use Zabbix extensively for monitoring the Druid cluster and monitoring the health of the cluster, and also this Zabbix the cluster, once a Druid setup in the previous slide, once the Druid cluster is provisioned, and also all the setup of its components and the configuration of the Hadoop is also done, and then there is another playbook that installs automatically the Zabbix agents, adds the discovery rules into the Zabbix server, and enabling the alerts, and also configure the triggers for the new cluster is also be done by the playbook. So, and then it also enables the problem alerts and the recovery alerts for all the new cluster that is enabled. So this, if you talk about, yeah, you can, Zabbix you can, and you can click it. So this is an all-in-one solution for alerting and monitoring, and this simplifies the say for example, it improves, so if any outage happens, before outage happens, so this Zabbix plays a major role for the availability of the cluster to the business. So it diagnoses and it captures the problems, and also say monitors basically and plus sends the alerts for any problems in the Druid missions. And also the one big advantage of the Zabbix is, right, we run the canary job, the canary and the canary query job in frequent intervals. So it just alarms the pager, the on-call person if there is any issue in the Druid cluster in terms of ingestion job or in terms of the if there is any performance. Say for example, the query execution minimum execution time is in seconds. So if that particular use case is the query execution time is exceeding beyond no 5 seconds, there is a critical threshold configured, immediately it sends alert to the on-call person. So such kind of mechanisms, alerts is implemented using the Zabbix. And for each components of the Druid, we customized and created the Zabbix templates for every category of the Druid service. Say for example, if in future there is any new cluster is added for overload, that's similar, that the same unique template is inherited for the new cluster. So it's going to be a one-time investment of configuring the Zabbix, and then while adding the new cluster, it's going to be quick. Yeah. So we just go to the next slide. So this is also part of the metrics that are we are capturing for the from the Druid cluster for our R&R, and also for the KPIs that helps to define the KPIs. So we all know that Druid generates the metrics related to queries, ingestion, and also from for the different endpoints. So what we do from this is to generate the heat map. So the heat map is the famous one, pretty much for that shows the success query count versus fail count at any point of time, and the time taken for by the query for each brokers at the having almost around 15 to 25 brokers, each broker how it performs. So all these kind of metrics are captured from the Druid emitter metrics, and then the top end runtime of the indexed jobs. And say for instance, I could recollect there's an handoff alert. If there is no handoff is happening in the, and how many times the handoff is causing issue per day, and so all handoffs happen versus number of handoff failed. All those metrics are captured, and it's just used just as a portal to get all those metrics and for arriving the KPIs. And also, so there is a time, say we have a capturing a typical get unique visitor, like Eric said, session and page view counts, and also the getting the obligated reports with various metrics from the top end values of the various dimension with the filters applied. All those things are also captured. And some of the we are almost crossing a 5.5 billion events per day. So these metrics and monitoring it gives the overall picture of the Druid performance from the infrastructure standpoint. And that's all. And Eric, can you go to the next slide? Yeah. Yeah, I think that's all I have from the infrastructure standpoint on Druid.
Please post your questions if you have any.
Thank you for that nice presentation, Erin and Maharaj. As I said, please post any Q&As in the Q&A tab, and we'll get to that. I can start with a question. Did you guys consider looking at implied clarity to monitor the health of your Druid clusters at all?
Mohan, you want to take the question? Mohan, you're on mute.
So, what's that question? Can you repeat?
Yeah, so you talked about how one of the challenges for the implementation of the Druid cluster is that it was hard to monitor the health and status of the Druid cluster. And you talked about how, you found ways to get around that. Did you consider looking at implied clarity to monitor the health of the Druid cluster?
No, we did not look into the implied clarity. No, so far. So far we did not try the implied clarity, and so far we are using the Apache Druid version for all our implementation.
Okay.
Does it answer your question?
Yeah, that answers it. If there's no other questions, I can ask a second one. When you're before you ingest that data, and this might be more to Arid, but when you ingest that data, do you do any configuring of your data model? For example, denormalizing your data before ingesting that?
Yes, we do a lot of processing before ingestion. We basically convert into into a proper, semi uh, structured data, and then we ingest it. So it is, yes, there are a lot of data formatting and transformation that happens to our data.
Great, thank you. We can maybe wait a few more moments to see if there's more questions, if any
Sure,
questions come in from the
definitely.
audience. Yeah. Okay, well, it doesn't look like there's anything coming in, so I just want to say thank you for your presentation and to, oh wait, there might be something here. Oh wait, so there's a question from Euclides that says, do you use Grafana for the Druid consultations, some data source? I'm not sure what that part means.
Do you want to take that question? Do we use Grafana for Druid consultations, some data source?
It's basically how are we using the Druid Grafana plugin, or what is that the question?
No, there is a question in the question answer window. If you look at the right side, there's a Q&A. Over there's a question.
Oh, sorry, it's the chat, right? I see the chat, and yeah, Q&A. Okay. Do you use Grafana for the Druid consultations? Yeah, some data sources. Yeah, basically the Grafana plugin basically is used to connect to the Druid data source and to get to to create the dashboards by the application team. So yeah. There is a plugin available, right? So from the Grafana, that yeah. There is an inbuilt plugin available, and that plugin will allow you to basically that will display the data sources, and from there you can just develop a nice dashboards.
Okay, great. It doesn't look like there's any new questions coming in. So at this point, I'm going to say thank you to all the attendees for attending the session. And thank you, Mohanraj and Arid, for that presentation. And we'll see you around Druid Summit.
Thank you.